Hi mathematicians, in this video we're going to look at some AP free response questions about implicit differentiation. This question is from 1998. It says, consider the curve defined by 2y to the 3 plus 6x squared y minus 12x squared plus 6y equals 1. A. Show that dy dx equals 4x minus 2xy divided by x squared plus y squared plus 1. They're giving us the answer and they want us to show the work to get that answer. So we need to find dy dx, which means we need to take the derivative. And because we have x's and y's intertwined, we should use implicit differentiation. So remember, in implicit differentiation, anytime you have the y, because we're differentiating with respect to x, we'll use the chain rule and multiply by dy dx. So here's our equation. Let's start taking the derivative. The derivative of 2y to the 3, move our exponent to the front. 2 times 3 is 6. Y, and we subtract 1 from our exponent to get 2. And because this is y and we're differentiating with respect to x, dy dx. For the next one, we have 6x squared multiplied by y. So we're going to have to use our product rule. Our first part is 6x squared, and the second is y. So remember, our product rule says we put the first times the derivative of the second. The derivative of y with respect to x is dy dx, plus the derivative of the first. 2 times 6 is 12. Subtract 1 from our exponent just gives us 1. Times our second, y. We're not taking the derivative of y, we're just writing the y itself. Then we have minus 12x squared. So multiply 2 times negative 12, you get negative 24x. 2 minus 1 is 1, we don't need to write it. Plus the derivative of 6y is 6. And then dy dx, because we have that y, equals derivative of 1 is 0. So now we've taken our derivative, we need to get dy dx's on one side and everything else on the other. First term will just go down, as will the second, and this last one here. All three of these have dy dx. Everything else we need to move to the other side, and when we move something to the other side, we change the sign. So if we have plus 12xy, we're going to do minus 12xy on both sides. And if we have minus 24x, we're going to do plus 24x, our inverse. So we get equals negative 12xy plus 24x. Now that we've separated our dy dx's all on the left side, we can factor out dy dx. So what's left is 6y squared plus 6x squared plus 6. So now that we factored, we have dy dx multiplied by everything in these parentheses, so I can divide it on both sides. So I'm going to divide by all of this. This will cancel, and I get dy dx equals negative 12xy plus 24x divided by 6y squared plus 6x squared plus 6. Now I'm going to check my work. It's not exactly the same. Well, if I notice, 6 is a factor of everything here. If I can divide everything by 6 here on both the top and the bottom, then I can do that. If I divide negative 12 by 6, I get negative 2xy. 24 divided by 6 is 4x. Divide by 6, divide 6, cancels, and again, and again. So now, do I have the same thing? Almost. I just have to reorganize it. So they wanted the 4x first, minus 2xy, divide by, then they wanted the x squared first, y squared plus 1. So now we've shown that dy dx is equal to that. Let's look at the next part now. Write an equation of each horizontal tangent line to the curve. If a line is horizontal, that means it's not going up or down. It's staying flat. So our slope is 0. And remember, the slope is the same as the derivative, or dy dx. So I'm going to set this to equal to 0. If a fraction is equal to 0, that must mean the numerator is equal to 0. So this implies that 4x minus 2xy, our numerator, must be equal to 0. So let's play around with this to see if we can try and solve it. So have x in both of these terms and a factor of 2. So I'm going to factor out 2x. What's left here is 2, and what's left in the second term is y. So now we have two factors that equal 0. So we can say 2x equals 0 and 2 minus y equals 0. So we can divide 2 on both sides and we get x equals 0. Or if we add y on both sides, we get 2 equals y. So now we have an x value and a y value, but they're not for the same point. We have to plug in our x into our original equation and our y into our original equation to find the point. And the reason we want to find the point is because we want to find the equation of the tangent line. Remember, a tangent line is of the form y minus y1 equals m times x minus x1. So we need to find this y1 and x1. So when x is 0, let's plug it into our original equation. So here's my equation. Instead of x, I'm going to put 0. Well, 2y cubed stays the same. This term is 0 because it has an x. That's 0. And then we have plus 6y equals 1. Back in 1998, question number 6 was a calculator question. So I'm going to put this in my calculator, press y equals 2, and I'm going to use x even though my variable is y because that's what I want to solve for, plus 6x. And in y2, I'm going to put 1, and I'm going to press second, trace, 5, enter, enter, enter. That is my y value here. So I get y equals 0.165164. And for AP, remember to use at least 5 decimal places so you don't get rounding errors. So this is when we have x equals 0. So that's our first coordinate. And our second coordinate is when y is 2. So I'm going to plug in 2 anytime I see a y. I'm going to put a 2. Now I'm going to put this straight into my calculator. Y equals, could have simplified, but I don't want to make mistakes in my simplifications. So I put that all in. Y2, I put 1. Again, second, trace 5. Enter 3 times. Let's see if this will work. No sign change. Let me see if I zoom out. If I zoom out at all, I'm seeing that these lines don't really intersect. So I can say that this one has no solution. So I only have one point that I need to write an equation of the horizontal tangent line to the curve. So here's my point. I need to write it in this form. Now, remember, my slope is 0, right? We said our slope was 0. So this whole term will just equal 0. If I'm writing this out, I'm going to get y minus our y1 is this value equals 0 times x minus 0. And all of this is 0. And to solve for y, we're just going to add 0.165164 to both sides. So we get y equals 0.165164. So this is our equation of the horizontal tangent line. Let's do this last part. The line through the origin with slope -1 is tangent to the curve at point P. Find the x and y coordinates of point P. So they're telling us that our slope is -1. And remember, slope is the same as dy dx. So our dy dx must equal -1. Now, even if you were not able to do the first question, they give you that answer so that you can use it correctly in the following questions. So we're going to set this equal to -1. So now we can work our way through solving this. So I'm going to multiply this denominator to both sides, and we'll cancel on this side. So we'll get 4x minus 2xy equals -1 times x squared plus y squared plus 1. And if I distribute that -1, change all my signs. Now we have this equation, and we want to find the x and the y coordinate. If we need to find two variables, we need to have two equations. Well, let's see what else they tell us. The line through the origin with the slope -1 is tangent to the curve. So they tell us a point. This is 0, 0. The origin is 0, 0. So we can use our point slope form. Y minus y1, which is 0, equals m, which is -1, times x minus x1, which is also 0. So if we simplify this, we just get y equals -x. So now that we have a value for y, we can use this to solve a system of equations. We solve for one variable and plug it into the other equation. So here's this equation again, and anytime I have y, I'm going to change it to -x. Here I have y times -x, so I'm just going to change that sign and put that x in there, equals -x squared minus, here I have y again, -x squared minus 1. So now let me put this in my calculator for x plus 2x squared. X times x is x squared. And y1, and in the other side, -x squared minus -x squared minus 1. And second trace 5. Enter, enter, enter. So I get this x coordinate. So if I now plug this in, my y value is the opposite sign, so I get y equals positive 0.5, because negative gives us positive. So I found my x and y coordinates of point P. We're going to look at an AP Calculus free response question from 2015 about implicit differentiation. This is question number 6, which means it is not a calculator question. Consider the curve given by the equation y to the 3 minus xy equals 2. It can be shown that dy dx equals y divide 3y squared minus x. Write an equation for the line tangent to the curve at the point -1, 1. Now sometimes they'll give you the y value, and sometimes you'll have to solve for it. If that's the case, you would plug this x value into your equation and solve for y. But we don't need to do that for this question. So we just want an equation for a tangent line. So when I see tangent line, the first thing I should think is my equation y minus y1 equals m times x minus x1. So we have our y1 and our x1 from this point. The first one is x, the second one is y. And to find our m, well, m is our slope, and slope is our derivative. So to find this m, we're going to have to find dy dx at the point -1, 1. So we're going to plug in this point into this equation. So our y value is 1, divide by 3 times our y again squared minus our x, which is -1. So if I simplify this, 1 squared is 1, 3 minus a negative is plus, so 3 plus 1 is 4, is 1/4. Now you don't need to simplify if it's a free response question. In fact, you can just write this whole messy thing as long as there's no variables as the m. So we have y minus y1, we said is 1, equals m, which I'm going to write as this big messy thing, just in case I make a mistake, parentheses x minus, and x1 is -1. So I'm going to put -1. And again, I'm going to leave it that messy. I don't want to get points off for simplifying or for algebra mistakes. So I'm going to leave it like that. If, however, you did simplify and you did put it into y equals mx plus b form, this is the answer that you should get. But again, leaving it messy is the way to go on a free response. Next, we want to find the coordinates of all points on the curve at which the tangent to the curve at that point is vertical. So if we have a vertical tangent line, that means our slope is approaching infinity. Or if we have a fraction, the denominator of our slope is 0. So dy dx has denominator 0. So we need something over 0. That's what it means to have a vertical tangent line. If I want my denominator to be 0, my denominator is 3y squared minus x needs to equal 0. Again, I'm looking at my dy dx. In the denominator is 3y squared minus x. And to be a vertical asymptote, the denominator must be 0. So now I need to solve this equation. You might be thinking, I have two variables. How can I solve this equation? Well, we actually have another equation as well. We also have the original function, and it says on the curve. So if it has to be on the curve, we also need this equation to be true. So we have two equations, two unknowns we can solve. The first thing I'm going to do is solve for x here, because that looks like it's the easiest part. So if I do plus x on both sides, that's just going to give me 3y squared equals x. So I've solved for x. I got x by itself. Now I've worked with this one. I'm going to take my x value as this function and put it in for x over here. So I'm going to get y to the 3 minus, and instead of x, I'm going to put 3y squared times y equals 2. So let me simplify this a little bit. 3y cubed minus 3y. If I have y squared times y to the 1, we add our exponents, so we get y to the 3. 1y to the 3 minus 3y to the 3 gives me negative 2y to the 3. They're like terms, I can add them. Then I can divide negative 2 on both sides. And that gives me negative 1. So I get y to the 3 equals negative 1. So I could take my cube root, or my 1/3 power, to get rid of that. And that gives me y equals negative 1. Now, a lot of students stop here. They think, oh, I'm done. But we only found the y value, and it wants a coordinate. A coordinate has both the x and the y. So we're going to take this y value and solve for x now. So I have 3 times, and instead of y, I'm going to put negative 1 squared equals my x. Negative 1 squared is positive 1 times 3 is 3. So I get 3 equals x. So I'm not done yet because I have to write this as a coordinate. So my final answer is 3 comma negative 1. So at 3, negative 1, there's a vertical tangent line to the graph. And if I graph this function, I can see right here at 3, negative 1, there is indeed a vertical tangent line. So some key takeaways. The equation for the tangent line is y minus y1 equals m times x minus x1. And use dy dx evaluated at your point to find your m. Next, if you're asked to find a vertical tangent line, dy dx must have 0 in the denominator so that dy dx is approaching infinity. If you're asked to find a horizontal tangent line, dy dx must equal 0, or you have 0 in the numerator if it's a fraction. And finally, in order to find the coordinate, use systems of equations. Remember, your two equations are your dy dx and your original function. And you'll use those to find the point. Always remember to persevere, mathematicians.